Hey guys, kind of want to show you this Model 14 that I've been working on, slowly fixing up for a friend of mine. He's eventually going to put more air switches and whatnot attached to it and signals, but this is what we have going so far. I have that signal from St. Louis Union Station. It is an EP, so electro-pneumatic, it runs on air. And then I have a color light subway transit signal here connected to the machine, as well as that subway signal connected to the machine. When I got this, it was a bunch of parts. We've got the model board working. We put in a PLC down here that controls all the logic within, takes all of the inputs from the levers and turns on light bulbs and outputs. All of these here are the field wiring. They power all the relays. For now, I just have a couple of track circuits and a couple of signal relays. Then it has quick disconnects for the air hose, as well as powering connectors. This connector here powers the CP valve, another union switch and signal. This controls the air to the switch machines. Then for compact, we are using an A10 air operated switch machine from the Chicago Transit Authority, and we have a switch indicator on here for the heck of it, because at this point, why not have fun, right? This is gonna be a little bit of a long video. We're gonna go ahead and let's see, we're gonna send a train to R4 and on, and then we are gonna bring a train into L6. I don't have L8 past the station yet. Some of the main parts to this is called a model board. Here is a gauge that shows the air supply, voltage gauge. These relays, or these timers right here, were for if the track circuits, which are lit up when they are normal, so no train on it, so they turn off when there's a train on it. These two track circuits right here, there's a switch in there. So these timers are used to override the track switch. So in case the train derails and you need to throw a switch underneath of it, I know as weird as it may be, or I'm sure somebody will correct me, but if they're doing maintenance and there's a train right here, but yet you need to throw that, we would say, let's take that track down. As you can see, the light went off. And our switch 7 light went off, meaning that you can't throw it because the track is occupied. So if we try to take our lever, it won't even go. So what you could do is you could run time on that, and that will eventually run down, lighting our switch light back up, which will allow us to operate our switch lever. But for time, let's put that back. Let's put that track circuit back, which we now see we have our switch lit up. If we watch here, we're going to take our lever and throw it over. The cool thing about this is if my buddy doesn't want to set up all of this in his basement, he can easily not wire this in. And you'll notice that when it's not wired in, it's no longer getting this switch indication, so my light goes out. We have a control box here. We can set that switch. I haven't made any labels, but we can set that switch down, and it will simulate the switch status. So now we can see our light is on, is showing reverse, our lever is reversed. We can see switches out of correspondence. It is moving. When that light went off, the green light turned on, indicating that it is normal. Throw it. So let's line R4 here across. Switch is normal. Traffic levers are correct. So you can hear it's got a tad bit of an air leak. I mean, it was buried for 30 years at a model railroad or a narrow gauge railroad until we dug it up. And we will go ahead and throw L6 into L8. And we're going to walk back here like I said, it's gonna be a little bit of a long video. Heard the train on the track. So this is our L6 signal. Ignore the number board there. I'm sorry. That is, yes, L6. That is L8. That is R4. So we already have a track out close to R4. That is the approach track to L6 here. Sorry, I'm shaking here, guys. It's gonna be a minute. There we go. So our train took over L6, which is that track there and that track there. So there's L6, it passed it. We can see our train is approaching R4 here. That is the approach before R4, because here is R4. Those indicators right there tell you that that lever is ready to be reset. So if we take this lever, we put it there. L6 has a mechanical or a electric timer on it, but L8 here has a mechanical timer. So if we throw that back, you can kind of hear there's a clockwork timer and they're on a pendulum that moves back and forth, and you adjust the weight to more time or less time. But it has to run through. We can see that one picked up. We can all right, we're about to get a train passing our R4 here. Hopefully within the next couple of seconds or so. There we go. So now our train has passed R4, and that's why that signal went back to stop. It also has a mechanical timer, so you can see you can put it there so it winds down. This one has already finished its time, so we can reset it. These buttons were for whistles at either end of the interlocking. These buttons underneath it here are called call on signals. So when you threw this lever, you can press this button, which it stays in, and it resets when the lever is restored, but that would be for the call on indication. We can see here our track is out, and that's because there's a train sitting on top of it. So we can't throw the lever whatsoever. This is the mechanical locking. This prevented the operator from making errors. There are little things here called lock dogs that move on these rails, and then there's rails in here that push them and stop them from colliding. Let's see if we can. You can see when I turn our traffic lever here, it turns that, which moves that lock dog. And then we have electric locks in the back. And that is, oh yeah, here. The call on signal or button is pressed. You can see when you restore that signal, it pushes it back out. This one. Yeah. Pretty cool. We're slowly getting there.